everyone, Professor Michael Scanlan here. Am I in a different room every time? Who does this? So today we're talking about Archimedes. Hopefully you can see that because the glare is kind of rough in here. So Archimedes was an incredible person, historically, scientifically. I highly recommend you look him up. I mean, just an incredible, I'm sorry, I'm trying to get situated here. Just an incredible person all around. Look him up. Today we're specifically going to talk about Archimedes' principle. Now that has to do with floating bodies. Now there's a legend of a crown, and it's really tied to the story of an incredible ship called the Corona. I guess that's kind of appropriate. Anyway, Corona means crown in Latin. Check out Archimedes and try this experiment and variations of it at home. So one thing you will need is a scale of some sort that you can set to 0, or you have to do a little bit of calculation, but other than that, as long as you have a scale, you're good. So I've got a scale, I'm cheating, that I'm going to turn on and wait for it to load up. So I've got containers of water here, and we're going to investigate floating objects. Now for my floating object, I've modeled or molded a piece of clay into a very ugly, rough boat shape. It doesn't have to be pretty, right? It's just got to float. So my scale is at 0 right now. You're going to need a container of some sort, and I'm going to put it on the scale, let it settle out. Now if you don't have a scale that has a tare function, T-A-R-E, or a 0 function, you're going to want to write this number down, because whatever you measure later, you're going to have to subtract the weight of the container from it. I'll explain as we go. So set your container on the scale. Stay on there. There you go. And if you have a tare function, if you can zero it out, I'm going to go ahead and 0 it. And so what this does is this scale automatically calculates, okay, anything I put in here, we're going to pretend that this doesn't exist. We're not actually taking the mass or the weight of this. So that's nice. So I'm going to bring in a container of water and put it in here. Now you got to be careful with this part. Not only because you're a scientist and you decided to wear a white shirt while you're dealing with food coloring. Brilliant, wasn't it? But also because you don't want it to spill prematurely. So you want to fill up a container in your tray, whatever you happen to have, a baking dish, whatever, until it's about to spill out. Now mine is about to spill out. If I put any more, it's going to start spilling. And you're going to take your object, whatever it happens to be. You can take a small jar and put something in it, something light, and then seal it up and use that. As long as it floats, you can use this and you can duplicate this experiment. And why don't you try different things, try different shapes. I'm going to put my boat in the water, and what do you think is going to happen? It's going to spill. Now you're just going to let that sit until it's finished dripping out. Are you finished dripping out? Okay. And I'm going to take my, oh shoot. Now Professor Scanlan has messed it up. Take it out and be very careful with it. I am not being very careful with this. And I'm going to weigh this water. Now I've already set my scale to be 0 with just the tray, the empty tray. Okay, stay put. So if you don't have that, hold on, what are you going to read? So my scale is telling me that I've got 25.9 grams of water in here. If I don't have a scale that has a 0 function or a tare function, then what I would do is I would take the weight or the mass, whatever you're measuring, of the tray, and then with the water in it, weigh it, and subtract the weight of the tray with the water. Subtract the weight of the tray from the weight of the tray with the water. So if the tray weighs or has a mass of 100 grams, for example, and you put it on here and it reads 125.9 grams, then I would take that 100 grams out of the measurement, and that tells me I've got 25.9 grams of water in there. So even if you don't have a zeroing function, this will still work. Okay, so we've got 25.9 grams of water in here. I have messed it up in trying to get this thing out of there. Did not do a good job. I even wound up with water in my boat. Apparently I'm not a good boat builder. I'm gonna reset my scale to be 0 again. Okay. And I'm going to take the mass of my boat. Now, the mass of my boat is way off. I'm not going to tell you what it is. If you do this right, okay, Professor Scanlan did not do this right, and I think I just got blue dye on my shirt. If you do this right, what you'll see is the weight, the mass of the water that's displaced, okay, and the weight of the object that you had floating are going to be the same. All right? Be clever about it. Try to get it to work. There's a famous professor, I say famous, he's not very well known unfortunately, but he's famous to me. Julius Sumner Miller. And he did a lot of videos similar to this a long time ago. And he was very famous for saying when something went wrong, he would say, I failed to provide the right conditions for the experiment to work as predicted. And that's exactly what happened here. My numbers didn't match, far from it. It's not that the principle doesn't work, it's I failed to provide the right conditions for the experiment to match the prediction. Sometimes that happens in science, and that's okay. I hope you give this a shot. I hope you do a lot better than I did with this too. All right, everybody, stay safe. I'll see you in the next video.